Okay, I guess it's time to start. So hello, welcome everyone to my talk, Java Migrating to 11 in Real App. My name is Piotr Przybył, and we are Devoxx Ukraine, if you didn't see that before. Shortly to introduce myself, my name is Piotr Przybył. I was told that to Ukrainian my name would translate as Piotr Przybył. I believe that's true. You can send your messages, comments or hate here. I'm self-employed as a remote freelance software gardener, which means when I leave my sleeping room or bedroom, my workplace is second door to the left. That's where I work. I'm also working as a trainer for a few companies, one of them being Cementis. I'm working for quite a few years in Java. I've done a few migrations, across a few major versions. I'm also so haunted by Java that when I'm on a holiday in Spain, Java is right behind my back, so be careful, guys. We've already covered who are you, because we did this little voting before, so we are mostly Java developers who want to run their stuff on Java 11, and that's cool. So agenda for today. We're going to talk about crucial non-technical changes, about removed and deprecated stuff, and also how to run your application on Java 11. What won't be covered today is all the new stuff, like new API, new var, this type indicator var, new tools or so ever. So if you came to this talk to learn Java 11 in 50 minutes, sorry, it's not this talk. This talk is about running the application you already have on JVM 11, basically. So let's start with this Oracle JDK versus OpenJDK. Who knows OpenJDK? Okay, many of you, but I'd say like a half. So if you don't know that, both are released by and maintained by Oracle JDK. By Oracle Corporation, Oracle JDK and OpenJDK. The differences are, there are some differences, but let's start what makes them similar. Technically they're mostly similar. They're mostly the same. There are some corner cases when they're different, like the edge of the world, when you need to take care of the turtle not to fall down on the elephant and so on. They're mostly technically they're mostly identical. There are some differences, of course, when it comes to licensing and money. Then they are different because the first one, Oracle JDK, is of course paid in production, as we know since Java 11. This one is free. So in terms of legal use, they're not exactly the same. And of course, there's this new release schema. New major release of Java is released every 6 months, and it's not postponed by any features. If a feature doesn't make it, then it's like unmerged or doesn't get merged, like we saw with raw strings for JDK 12. Oracle releases for their JDK a new LTS version every 3 years. So we had Java 11, the next one will be Java 17. And this also means that from Oracle's point of view, there's an instant lack of support for OpenJDK. When Oracle releases a new version of Java, new major version of Java, they instantly stop supporting that previous version of Java in OpenJDK. So there's this slide, you've already seen it during Professor Hosman's presentation. So there are colors. I hope we are not colorblind, as many developers. So there are these gray boxes, as you can see. There are these pinkish boxes, and there are red boxes. All we have in this slide are JDKs maintained and delivered by Oracle Corporation, right? So these great ones are basically OpenJDK. And as you can see, every 6 months, Oracle releases a new version. This means they stop supporting the previous version. This also means that we have so-called support cliff. This pinkish version means paid JDK, and also the red one, this is an extended support, and this is just a support, commercial support. And this leads us to this very interesting triangle, meaning that your JDK can be either, provided you choose a JDK from Oracle, of course, it can be either, you can be secure, free, and stable, and you can choose 2. You can't choose 3. So if you like to be secure, I assume you guys would like to be secure and have all the bug fixes and so on. Then you either have to choose OpenJDK, which is free, but it's not stable, meaning every 6 months you need to upgrade. Or you have, if you want to be stable, like this one, like no need to upgrade to every new version every 6 months, then it's not free in production, as we know, per CPU and so on, so on, so. However, we need to remember that there are also other vendors and JVMs. I can show that in SDK man, for example, SDK list Java, and here we have the list of JVMs available in SDK Manager. As you can see, there are some versions from Adopt OpenJDK, from Amazon, Azure, also from Amazon and other vendors. I mean, SDK man doesn't list all possible JDK under the wall, because there's also Red Hat, there's IBM and others. So we need to remember that Java doesn't mean that, for example, getting Java or a new version of Java doesn't mean you need to go to Sun's page or Oracle's page and download a new version of Java, like that the Java comes from there, basically. And you can repeat after me, because I also do trainings on migrating to Java 11, and I was quite shocked that like 3/4 of the people during the entry poll, they say, okay, it's nice to have such a training, but we are not going to migrate to Java anyhow, because Java 11 is paid. This is what they say. Java 11 is paid. I mean, it has been written on all the forums and elsewhere. And every time I see something like this, I think that the person who wrote that was wearing a nice tinfoil hat. Just like this. I mean, there are people who are wearing tinfoil hats, right? There are people who believe that the earth is flat. And also the same people keep saying that Java 11 is paid. I mean, this is the same level of rubbish from my point of view. So I ask you now to repeat after me that Java 11 is not paid. Come on. Java 11 is not paid. Louder. Java 11 is not paid. They didn't hear us in the other rooms. Come on, louder. Java 11 is not paid. Exactly. Remember that? Stop saying rubbish and stop wearing tinfoil hats. They all make you look stupid. Java is still free. You can follow this link if you don't trust me. What you can do, you can go to Adopt OpenJDK, for example. You can select one of the versions. I hope it's not going to be Java 8 anymore. You can select the JVM. Then you can select the platform. You can select Docker. You can select various operating systems, or you can select Windows, if you will. So this is the way to get open and maintained JDK. Because what OpenJDK does is, once Oracle kind of abandons OpenJDK, they take over this build and still support it. I mean, they are backporting security fixes and so on and so on. As far as I know, but I might be wrong here, Java 11 is still maintained as, I mean, former OpenJDK 11 is maintained by Red Hat, and we see that as OpenJDK. Simple. So there's still a free and available and up-to-date Java 11 for you, or I mean for all of us to use. Do you recognize this slogan? Who recognizes this slogan? Okay, I recognize it too. Actually, it was this, right? It was working like this, because I remember porting the code like from Windows to Solaris or vice versa. So there was this promise that Java code will run everywhere, but sometimes there were these corner cases where it actually didn't. So when you get to kind of release notes from this Java 9 or 11, like from what Oracle said about migrating to the new Java, we can distill actually such a sentence. It has two gotchas, as you see, and it says that normal Java standard edition applications should just work. Question number 1, is your application normal? Who knows that? Maybe it's normal, maybe it's not. Another thing is this should, that it should just work. I mean, should doesn't say that it will work. It's not fixed guarantee. It's kind of softish guarantee. And of course, I mentioned two gotchas, so there must be a third one. It's this standard edition. If you have anything enterprise-y in your application, it's not covered by this standard edition anymore. So this sentence doesn't even apply to your code, to your system, to your application, whatever. Therefore, in all other cases, the migration might not be a simple and single step. And this talk is about this. So before we go to migrating to Java 11, we need to convince someone, right? We need to convince the business, the bosses, the managers. Someone needs to assign time and money and say, okay, Johnny, off you go. You can do that with Ivan or with the other guys. We are going to migrate our application or to try to run it on Java 11. So how to convince them? What arguments should we use? Because I've been in this place twice, I need to convince the business or product owners or basically the dragons that were keeping the money that it's really worth the money, okay, the treasure. And here are these arguments for you. First is Java Flight Recorder and Java Mission Control. Due to this new release cycle, Oracle decided to open source Java Flight Recorder, so it's no more commercial feature which has to be unlocked. Therefore, just like a black box in a plane, you can record how your application performs in runtime with reasonably low overhead, like 1 or 2% if you configure it properly. And then when your application, for example, crashes or you'd like to investigate how it behaved during this flight at runtime, you can use Java Mission Control to open this black box and analyze the data from the flight. String has array of bytes inside. I mean, we have since Java 9 compact bytes, meaning if your string is keeping the characters from Latin 1 character set, it's going to occupy half the size in the heap. Meaning if you have like escaped XMLs or stuff kept as strings, they will occupy only half of the memory compared to Java 8. And this is the instant benefit when you like pay for every megabyte of RAM in a cloud or something. Application class data sharing. Now, I mean, with every version it gets improved. In Java 13 we have even dynamic application class data sharing archives, meaning that when your application or with Java or bootloader/class loader is loading this whole long class path, and there are many jars with many classes and so on, Java has to perform the stuff like more or less Tom Cruise did in Minority Report, right? So it has to pick all this stuff, put it in right places, I mean, which class, which methods, from which jar, and so on. And when you boot your application many times on the very same machine, or you have many instances of the same application at the same machine, you're doing it again and again and again, and it's just a waste of time and RAM and precious CPU time. So we can recall this whole image, dump it to a file, and next instances can simply read this file, or actually even use the same piece of or area of our RAM and access it in to read-only mode. Therefore, we save time and money, and we have better startup time. If you don't know what Ape CDS is, I really encourage you to take a look at this, because it really saves time and money. Since Java 10, we also have better integration with containers. I'm talking like Docker. For example, it now obeys correctly the limit of the CPU, so you have assigned to a certain Docker image. Other big changes, in my opinion, like we have finally Java unified logging. So there's a one unified parameter to log every internal of the JVM when it's running. Not dozens difficult to remember parameters. Just everything can be logged in a single unified way. We have, of course, Java Platform Module System / Jigsaw, which is a huge change on its own. We have JShell. Finally, Java has REPL. I mean, Scala had it, Groovy had it, all the languages have them, except Java. I mean, and now we have that in Java as well. So, see, we can go like JShell, and we can, for example, do system out print line and say hello. Sorry. Hello. And you see, to try a piece of Java, you don't need to create a file, you don't need to compile, you don't need to run it. You can just open JShell and give it a spin to see how this snippet of Java works, basically. We have this type indicator, so it works for local variables which are instantiated instantly. So we don't have to create all this long type of the variable. You just put var, and therefore the compiler will infer it for you. Like again in JShell, I can do like var1 and say hi, and then 1 is inferred to be a string. I don't put it that string, and I mean for string or integer, it's not a big save. But when you have this buffered reader of something, or when you have this list of maps of list or something, you know, these generic types, then it can be a real saver, right? And we can write scripts in Java. I mean, like proper scripts. This is not JavaScript, just scripts in Java. I hope I'll show you that. And also Java finally is removing stuff. I mean, Java is getting rid of this ball and chains which were slowing its development in time. So I think Java is moving faster and faster because they are not trying to keep the full backward compatibility. Some classes get removed, some methods get removed, and we have to deal with that, basically. So let's talk about this removed stuff. First, all these all these modules which were enclosed in Java.Standard Edition Enterprise Edition module are gone now. I mean, they got decoupled, meaning that if you have like web services, who's running web services in Java or web services client? Yeah. So if you, for example, guys, were using these web services or anything here starting with JAX-B, and now you had to add separate dependencies, basically, because they are not part of the JDK anymore. They got like hidden for Java 9 and 10. Since Java 11, they're just decoupled. If you're using Corba, is anyone using Corba? Okay. I mean, get the jellies. I mean, you should. Can you pass it to me? Because you're a poor guy, you still have to use Corba. JavaFX got decoupled. Applets got removed, of course. Java Web Start is also no more. Many XX parameters also got removed because they were there for backward compatibility. Even if they didn't do anything, they were still there. So now instead of like almost 800 parameters, if I call that correctly. In Java 11, we had 500 something, so many of them got removed. And of course, many methods from sunmisc unsafe got removed. Question, who's using sunmisc unsafe? Excuse me? Shout it out. Come on, you deserve jellies as well. Come on. Great. Who's using Spring? Keep your hands up. Who's using Hibernate? You guys are using sunmisc unsafe. Only you don't know that. Okay? The guy in the second row knows that. That's why he got jellies. There's of course much more removed stuff. You should read the lists. Here they are. I mean the links of the removed stuff for various versions of Java. And let's talk about the deprecated stuff, because now we have a concept called enhanced deprecation. Do you know this annotation? Who knows it? Do you really know it? Or maybe you confuse it with another annotation starting with lowercase d. Because so far we had this lowercase d deprecated, and it was kind of I used to call it the Heisen annotation, because we weren't sure if this stuff is just bad to use, like we shouldn't use it, or maybe it's the stuff that's going to be removed somewhere in the future. Now we have this enhanced deprecation and the big D deprecated annotation, which can have for the removal set as true, meaning now the vendor of this API, which is annotated like this, doesn't make any guarantees that in the next version, this piece of API, like method or class, is still going to be present. Meaning, if you see a method, for example, in Java, annotated as this deprecated with for removal true, this means in next Java release, this method might be gone. So how to detect it if you're not compiling the code or you have disabled the compiler warnings, because who cares about compiler warnings, right? Then you can use JDepreScan, and you just fit it with the class path, and it will tell you that, for example, this jar is making a call to a method or a class which is deprecated for removal. So you should take care of this. Of course, concurrent mark sweep got deprecated, and as far as I know, in Java 14 it's going to be gone, so better stop using it. Nashorn got deprecated if you're using JavaScript. In my opinion, dip reflection also got deprecated. Who knows what dip reflection is? I am looking for a brave soul. Who knows what dip reflection is? Nobody. Okay, so dip reflection happens when you summon the demons of the dip reflection by calling set accessible true. This is the dip reflection, because when you just, let's say, instantiate an object by its name, or call a method by its name, and it's public, then it's like a shallow reflection, kind of dynamic thingy in Java. Whereas you need to get to internals of something, then you're making a dip reflection, basically. And this is evil, trust me. So of course, modules, the jigsaw. Modules are everywhere. Well, yes and no. Of course, they are part of JDK. I mean, JDK is modular now. For example, we can see that as well, I believe, here. Let's see which Java version we have. Java version it's 11, so we can see Java list modules. And see, and this is the list of the modules for Java 11. So JDK got modularized under the hood, but will our libraries and applications get modular? That's not so sure. I really like the quote from Professor Horstman's book when he says, if I remember that correctly, that modules in Java are kind of social experiment. We don't know if they're going to catch or not. So why they introduced modules? First of all, to get rid of this jar hell. Who knows what jar hell is? Anyone? Yeah, many experienced souls. I'm with you, really, with all my heart. So if you don't know what jar hell is, basically, you had this clever admin, yeah, right, who saw that there are 3 applications running on Tomcat who are using the same jar library. So he took the library, put it in Tomcat's sleep directory, then you released a new version with a new dependency, but Tomcat used the previous version of this library because it found it in its own libs directory, right? So like basically the class path is read in a linear matter, so whatever is found earlier just simply wins, basically. And this is not more the case with modules, because in modules every package can belong only to one module, and one module means one jar file per standard. Therefore, there's no jar hell with modules. And in my opinion, it's also about better encapsulation, so lifting the encapsulation to the level of architecture, because we know all this private, protected, public, and this default access, right? Only they work for classes and for classes internals, but they don't work for packages. And now with modules, we can have kind of similar encapsulation, only at the level of packages. So you make classes in your .impl package, but they are public for, let's say, for testing library, not for the junior developer from the neighborhood team to use. And with modules, you're able to specify that. I mean, who can call even the public members from a certain package. So it's like to move us from class path to module path, I would say. So if you wish, you can repeat after me again, because people also keep saying that in Java 11 you need to have modules and module path to run it. It's rubbish. You don't have to. You just can stick to class path. Of course, you can migrate, or maybe you should start a new project using modules if you want to lift your application and make it more clean code-ish, solid and so on, using Java post 9 features. But it's not obligatory, so you can still have class path. But JDK is modular. There's no more RTjar. As I have shown you, I have many versions of Java installed at this machine. But when I try to find this rt.jar file, it exists only for Java 8. So for Java 9 and above, there is no rt.jar file. Basically, it got removed. Okay, so migration steps, because I've been through this migration. It's not a simple process. It's not a single step. I mean, if the code compiles, it's good, but it doesn't mean the code will work in production. Therefore, I made these steps, and I kind of suggestion for you to follow if you have to migrate your applications and make them run on Java 11. So here are the steps for you. Step number 1, install SDK Manager, as I have shown you, because in one tab you can have Java 11 and the other Java 8, like Java version. Here is Java, yeah, exactly, because it's the 8, so it recognizes only this. So here I have Java 8, and here I have, as you have seen, Java 11 at the very same machine in different types. So it's dead simple to run the same application in different versions and see how it behaves, how it performs, if it's exactly what you need. Then you should upgrade your RDE. If your IDE is 2 years old because you didn't continue with your license, I think you should upgrade it, because yeah, it doesn't support the old version basically. Also, what you should upgrade is all these build tools. Like you should upgrade your Maven or Gradle. If you have a CI like, I don't know, TeamCity, Jenkins or whatever, it should get upgraded as well to recognize the new format, the new bytecode version and so on. If you have any containers like JBoss, of course, I hope you're not running JBoss, but this Wildfly, Tomcat, or whatever, you should upgrade it as well. Because let's say some ancient Tomcat 7 versions are not okay for Java 9 or post 9, whereas the newest versions are okay with that. So we need to upgrade at least the minor version. And of course, you should upgrade all your dependencies in your POM and or in your Gradle build file. And I hope you really do it on a daily basis. But if in case you don't, there's a time for you to do that finally, okay? Because trying to run your application on Java 11 when you have Hibernate 3, I'm not sure it's a good idea, basically. Following migration steps, compile still for target version 8. And of course, try to run using version 11. If your application is heavily using this Java EE/Jakarta EE things or the packages from Java starting with JavaX, you might want to just do it with steps like with Java 9 or 10. Basically, because there's this joke in Polish, how to eat an elephant, and the answer is piece by piece. So if you have an application which is using or importing the JavaX packages, it might be easier not to jump directly to 11, but to do it in steps first to go to Java 10 or 9 or 10, even if it's not supported, just as a middle step in your migration. Then you need to add explicit dependencies for all these deprecated or externalized modules. And then, this is really important, guys, test and automate everything like crazy in each step. Especially if you're going to upgrade, like with every major version, or even not every major version, but we're going to have LTS every 3 years. So repeating these tests over and over might be stupid, right? So maybe it's a finally good argument to automate these tests and to see if everything is performing as it should. Extra migration steps, if you're releasing your own product, you might compile using 11 and try to see if it's still running using 8, because many people are using 8, of course. You may play with illegal access debug deny to get rid of the warnings. And to get rid of them, you can use one of these ads. And in general, 2 things might happen during this migration when you make yet another try to run this stuff. Of course, you might see some compilation errors, like missing classes, missing methods, and there might be some runtime errors, like problems with casting, or something missing. And there can be a third one, like illegal access, which is kind of a warning, which is not a strict error, but a warning saying that something might be wrong. So if you have a missing applet or corba, sorry, it's not going to work anymore. If you have something from this JavaX package, then you need to add one of the explicit dependencies. They're listed here by Nikolai Padlock, our new Java champion. On Stack Overflow. If you have missing classes or methods, I guess you didn't upgrade your dependencies in your POM file. If you have any missing XX parameters or DevOps team complains about that, I mean, they should read the changelog and upgrade the scripts, basically. So let's talk about this illegal access. I told you this is where you perform a deep reflection, because our code might not be modular, but under the hood JDK is modular. And I really like this, like, what happens when you overuse the reflection? I find this tweet from Sergey Yegorov really interesting. This is the usage of deep reflection. Yeah, so if you're using deep reflection, in the first place, you should try to get rid of it. But in case your boss doesn't allow that because budget, time, and so on, you can try to find out where it works. So the default option for illegal access is permit. This is how JVM starts. So it permits everything, and just when it encounters the very first illegal access, it will tell you you have illegal access somewhere in your app. Period. So I call it the friendly option. Then you can have like this illegal access warn, which I call the wife option. So every time you have illegal access in your app, JVM will complain that you have illegal access, Then we can switch to debug, aka a mother-in-law option, which is like your wife, only it will also point to exactly where it takes place. Like, here it is, here it's the illegal access, and here, and here, and here. We will use the stack traces. It's so picky, just like your mother-in-law. Hopefully not, of course. And then you can have this deny option, which I call father-in-law option, which behaves exactly like your mother-in-law, but you can commit the crime of illegal access just like with his daughter only once, and then you're dead. Okay? Then everything terminates, and that's why I call this deny option father-in-law option. And there's kind of promise, aka warning, that one day this will be default. It's not default at least till Java 13, but one day, remember guys. Okay, there are needed fives if you like to get rid of them, especially this one is the most needed at opens, which opens a certain stuff to be accessed using deep reflection without any warnings. To save time, because I prefer to show you some demo, we'll skip this, but I keep it to for you to a future reference. One thing is that everything you have in your class path ends up as an all unnamed module in this whole module graph. You need to remember that. So even if you don't use explicit modules, everything you have on a class path lands in an all unnamed module. So when you use this, and for example, your class path is using something from JDK, then you put here all unnamed as this module using reflection. Okay, sorry to skip that, but it's like we have to choose something. And if you have too many options like this, you can put them to a flat text files and just use them with this add notation. So you have add this file or add this file, just to save you, a lot of typing, because one library might require, let's say, 50 add opens, another might require 70 add opens, and so on and so on. That's why you can keep them in this flat text files, which can't be nested. And remember, guys, your migration won't be the same as the ones I had. Your mileage might vary, basically. So if you have like dirty casting of your class loader to URL class loader, it won't work. I didn't have this because I didn't cast my class loader, but I saw some applications doing that. I was happy not to migrate them. If you want to try trivial migration, you can find it on my GitHub profile. So let's switch to this code. So what this application does, where are we? Here. So there's a simple application, and it doesn't do anything special. It does just, what our applications do, like some string processing. So we have some beans, like Alice and Bob being children of John. We want to serialize them to XML using JAX-B and so on, because you see we have this JAX Javax XML bind imports. Then we want to create base 65 of John's first name to have it encrypted. Remember, this is not the way of making decryption. And then we summon the daemons of deep reflection in this deep look into method, and this is quite interesting because you see we get the value field from our string class, and we make it accessible, and you can see it's a character array, and it's Java 8. So when we run this application, Java 8, let's see the output. Yeah, so we see this is the XML being output. So we have the base 64, and we have the actual character array being kept as John's name. So we have J, O, H, N, and so on. What we skipped is this compiler warning, which says that this class is a proprietary API and might get removed in the future. And in fact, it got removed. So once we try to do that in Java 9, Java 9, yeah, and to run it, I mean, I've already migrated this stuff, so it's running. But the first obvious difference is you can see that there's no compiler warning. The base 64 is still the same, but we have something different in here. So as you can see in this deep look into, now we have to cast the internals of string to array of bytes, because the internals of string change. So if you have casts like this, dirty casts, they will crash in runtime. Therefore, we need to take care of them, and this is one of the arguments why we should migrate to Java 9 to save some RAM if you have Latin 1 strings. Another thing, see, we don't have this SunMISC base 64 something. We had to choose another API because that one got removed, and we have a new one to use. And yeah, so how does it work that we have this Javax XML still working? Well, as I told you, these Javax modules got excluded eventually in Java 9, but 11, but in Java 9 and 10 they got kind of hidden, so we had to enable them, and to enable them we had to use this dash add modules Java XML bind, for example, or you can use SEEE to just include everything. That's why it might be easier to do it in these baby steps, as I told you. If we don't use this add opens, like in here, and we still try to run this code, we'll see what happens if the mother-in-law is going to strike. Yeah, she does. As you can see, we can debug now where this illegal access happens. So it tells us that it's this deep look into inline 63. So let's see, 63, it's exactly this one. Yeah, making a field accessible. So if you don't want to scare off your clients because they're running your system using Java 11 and they complain because we see some errors, then you need to seal them, these errors, or basically tell your JVM or the JVM that everything's all right. I mean, it's not all right, but this is kind of like allowed stuff, and therefore for your Java process you have to just add opens that Java-lang package from Java-based module got opened to all unnamed, meaning everything we have in our class path. And finally, switching to Java 11, will look like this. See, and thanks to SDK Manager, I'm able to rapidly switch the versions of Java I'm using. That's why you should really try SDK Manager to use it not only for Java but also for Scala, Maven, Gradle, whatever. So nothing changed here. I mean, the output is exactly the same. The application behaves exactly the same. Only, as you can see, we don't have this add modules anymore because these modules in G11 got separated, and they got separated at their own artifacts. That's why we need to add them to as dependencies in our Gradle or Maven file. And this is an example how to make it work for JAX-B. For web services, you're going to have something more, and so on and so on. And the application behaves exactly the same as before. So see, we had to add external dependencies to seal these illegal access warnings. We had to add this, add opens. Basically, also in the application, we had to change the cast to avoid runtime error. We also had to switch to different implementation because the previous one is gone. So because of the NDA, I'm not able to show the real code, but I distill the issues we observed basically in our migration. Okay, a bit more about the other stuff. I should have a different project here. Okay, so let's say you have an application and it crashes and you don't know why it crashes because it throws out of memory error, right? Then you can use this Java Unified logging, which works like this. You set just the -x log, and here we say that we are going to log everything related to GC and at debug level to file locator tmp gc log. Is there something wrong with this command? Questions? I mean, my question, your answers. Do you think it's okay or not? No, why not? It's wrong because you don't log to TMP, right? I mean, it's only the demo purposes, so please don't quote me versus your boss that logging to TMP is okay. It's not okay, I only use it for demo. Also, what we can log is UTC, uptime, and so on. We keep up to 10 files, and each of them is 128 megabytes, and then you can open such a file, and it reads like this. Basically, yeah. So here we see, we can read somewhere in here that we were using G1, yeah, GC calls G1, as you can see, and this is the first pause. And when we scroll, there are some stats, what happened, then there's should be another pause, and so on. And when we scroll it down, just for 30 seconds, because you see here it's like almost 32 seconds of uptime, we get 200,000 lines. So you see, with the Java Unified logging, you can really log what's happening inside your application. So you can everything at hand, provided you didn't log it to TMP and the server rebooted, right? But what you can also do, you can use this flight recorder. And you can say that I want to keep my black box again as a recording JFR file, and these are the maximum sizes and so on, and this is the way I'm calling the application. So let's try to open JFR rapidly. Sorry, JMC, Java Mission Control. Looks quite ecliptish, right? And this is like, it's analyzing one of these recordings. And it shows you, like, as a result of pre-analysis, automatic pre-analysis, what's wrong with this application. I remind you, we didn't see the code yet. So you can see there's a problem with the G1 because it has long pauses here. The longest pause took, I can't read it right like now, but it's like, anyway, it's too long. See, there are GC stalls. There was not quite enough free RAM because the occupation was pretty high. And it can also show you with which threads we're allocating the objects. So we can see, you can read here that this thread was most likely named producer. And this analysis is even so freaking good that when you call your application with this, let me show you, with this what is your password baby argument, it analyzes these arguments and says that this argument looks suspicious because you shouldn't pass your passwords as an argument. Right? It's a stupid way because it then remains in your bash history and stuff. So this tool is so good. And finally, it's open sourced. I mean, with Java Flight Recorder, so we can use it for free. Okay, so we see that there's a problem with this app producer run, producer thread, because it's allocating so much memory. So finally, we can, I mean, provided we have the sources, you can take a look at the sources, and here they are. So where's the problem? Shut it out. I can't hear you. Thread sleep. Yeah, jellies. Almost there. Perfect catch. You must be catching exceptions as well, I guess. Anyway, yeah, thread sleep. The producer thread sleeps only for 50 milliseconds, whereas the consumer thread is sleeping for 100 milliseconds. Therefore, it's not a surprise that when we open this garbage collection chart in Java mission control, we see that the occupation of our heap is growing and growing until it reaches the XMX size, right? And we're not able to allocate anything else, and then that's why it crashes. And you can like zoom it in and see all these GC poses, like the longest pause, sum of all poses, and so on. If your application is relies on manipulating files, you will see a lot of operations here. Our application does a lot of stuff over the network. That's why our socket is always, I mean, the socket tab will almost always red, and so on and so on. Like, see, again, memory, you can see the threads, which threads were used, and live objects, where was that? Yeah, from memory, C class, and I see that for the byte array, we allocated more than 1.5 gigabytes. So this really shows you what happens in your application, and there are ongoing jobs to make it possible, even like not after the application crashes, but during the flight for next Java versions. So keep an eye on this. And I have promised you to show you how Java scripts now. So let's switch to Java 11. Yeah. So we also have this make var.jshell file. See, I'm using this type indicator var, and this looks familiar, right? Except this last command, which is exit, which tells JShell to exit. So you can, or we can JShell make var JShell, and it's running this script. So see, you don't even have to create like a class or something in a file to run it and see the actual output. And yeah, one more thing. Do you see this java.script file? I'll open it for you here. Does it look familiar? Okay, so why isn't it colored? Sorry? No, it's not the extension. What is it? I mean, the extension is one thing, but if I change the extension, it wouldn't work. Yes? Sorry? Shebang. Who shouted Shebang? I'm not able to throw that far away, sorry. But, okay, will you pass it to him? Thanks. Yeah, it's the shebang. Just like in a bash file or Perl file or PHP file, I'm able to tell my shell that please run this as Java 11. So see, I have such file. I don't have to Java C it. I don't even have to Java it. All I can do is, JavaScript, like this, and then it runs. See, it shows now since Java 10 that I have 16 CPU cores because of the hyperthreading and so on, and this is the amount of the memory. And of course, we have more and more Unicode emojis. I don't know what for, but we have them. Anyway, yeah. So this was the trivial migration and showing you some tools why this might be interesting, I mean, and worth it to migrate to Java 11. If you'd like to see what's new and noteworthy in Java 12 and 13, I invite you to my talk tomorrow at 10:30, I believe. If you want to see another sample migration, do you know this pet shop of Spring? The Spring app, yeah, you're nodding. So if you want to migrate it, there's a tutorial how to do that. I mean, you can try, you can learn why you didn't, what it didn't work, or what you should do to do extra. If you like this talk, you can have a training with me because there's much more in Java 11 to explore, of course. Duże dziękuję for attending this talk. We're almost there, folks. I would ask you, not only at this event, but always, at every event and for every speaker, to provide your feedback, because then it tells us what we should improve, what's okay, what's not okay. I accept feedback in any form, even as a paper form. Anything is okay. If you don't like the Devoxx app, I mean, I'm asking you for the feedback on the Devoxx app for all speakers, but if you don't like it, you can provide your feedback here for Google Forms. It's anonymous. The slides and all the links are here in this, under this URL. And this is my Twitter, if you'd like to follow me. And I believe we have like 2 minutes for questions, if there are any. Do you have any questions? I mean, I'll be today and I'll be tomorrow till the end of the day, so you can approach me. You see, guys, I really love talking to you. That's why we speakers are here. Remember that. But if you have any question right now, I mean, I'm out of jellies, but... Sorry? Sorry, there's a question with microphone. I'm really sorry, I can't hear you. The microphone doesn't work. Bloody technology. Yeah, it does.
It's work now. Hello. First of all, thank you for interesting presentation. And can you please tell us what was the difficult part of migration from 8 to 11? I'm pretty sure there existed some...
Yeah, I mean, why I told you that you should automate your tests and test like crazy. Because everything compiled, everything seemed to work, so I was happy to deliver to production. And then 3 invoices didn't get generated, right? They didn't generate, so I had to roll back. But the good part is we have the deployment and the rollback automated, so it was just a matter of pressing a button, and then I had to test it again and cover these cases. So what I really, suggest you to do is like compiling stuff is one thing, but thanks to all these pathologies we have in Spring and thanks to other annotations and so on, we really need to check all execution paths, really, because there might be some gotchas during runtime. Does it answer your question?
Yeah, I think so. Thank you.
More questions? No more time for questions, maybe. I don't know.
I guess we have. Just raise your hand if you have some questions, guys. Anybody? It's over here, the second row or third row.
How was this tool is called that you showed on Ubuntu?
Sorry, how was what called?
The tool that you showed on Ubuntu.
But which tool? I mean, it's for analysis. This.
Yes.
It's called Java Mission Control, and if you visit the webpage of Alexei Shipliev, he has the latest build available. So I recommend this. It's like, let's see, it's Java Mission Control, because it's like this. Your JVM, you enable Java Flight Recorder in your JVM, during the runtime, and it stores this file somewhere. And then there's this file you have to analyze, and this is the tool to analyze this file, being the black box, which is actually orange in real life. So it's called Java Mission Control. In the future, this might be like real time without the need to store this file. But it's really cool, isn't it? It brought your attention. I'm really glad.
All right. One more question, maybe. Somebody want to ask? No? Yes. In the middle.
Thank you for presentation and the question about a JProfiler or tool like that. So is it still actual, valid, or any URLs?
I don't see any reason why it shouldn't be working or valid. Or I mean, Java Flight Recorder, as far as I can tell you, is not meant to replace profiling. I mean, because currently Java Flight Recorder is actually used for the, let's say, after-death analysis, post-mortem, I would say. And it's like, it's very nice to analyze stuff and so on and so on, and it has a really low overhead. That's why, like, when you set it with like not super duper excessive settings, it should add like 1%, 2% overhead at production. So use it at production. But I guess for the like performance testing and boost, you'd rather use profilers in kind of production environments, right? So these are like, they're covering different scopes. Sometimes they interject, but not always. So these are different tools for different purposes. And one is okay, the other one is also okay.
Thank you.
Sorry, I don't hear the question. Yeah, it might be, I saw the jabs, yeah, Robert says that it might be possible to do it on runtime in, since Java or from Java 14. Yeah, Java 14 might be quite a breakthrough, actually.
One more question? Yeah.
If you have any?
Maybe, so yes, we have some person.
Okay, that's quite a long Q&A. I like it.
One question more. Did you estimate how to change value of heap after migration from 8 to 11? Because you said previously that do you convert string to byte array, yeah?
Yeah.
You said maybe in 2 times, yeah, or less. We use heap, yeah.
Yeah, because it was like this. Because they took a look at the actual real life heaps, and they like if you have let's say, let's skip to the first slide. I'll show it with an example. See, if you have a string with my first name, everything is in Latin. Therefore, this will just occupy 5 bytes because it's PIOTR. Whereas this, we have non-Latin L, which means every character has to be kept as 2 bytes. So if your whole string has just everything from ISO Latin 1, it will be kept just as 5 bytes. This will be more, you know, because it will be UTF-16. Basically, you don't have to worry about this unless you're doing dirty stuff and like reflection on strings or something. It's transparent from you if you use strings only as strings. You don't need to switch to change anything. It's automated, and as far as I can tell, you even can't opt out. Like it's going to be bytes. There's one more byte flag which says whether the string is ISO Latin 1 or not. I mean, we can take a look to string class. Because string, yeah, let's see. So it's an array of bytes, and we have this byte coder, which can keep if it's Latin 1 or UTF-16. So this is how it works. It's just internal stuff of JVM now since Java 9. Does it answer your question?
Yeah. Yes, and one more.
Yeah.
Did you see reduce of using heap? Yeah,
we saw tremendous reduce because during 1 minute of runtime of our application, we were mangling 24 gigabytes of RAM of heap. I mean, garbage collector had to garbage stuff and so on because I mean, certain parts of our applications, what they do is processing XML files. So thanks to this change, we came down from 24 gigabytes to, I mean, we reduced 4.5 gigabytes. So 4.5 gigabyte for 24 gigs of RAM, I'd say it's quite significant, right? And you save that much of your CPU, of your GC pulses, of the money you have to pay for the RAM. You can reduce your heap space or whatever. I mean, this is the money you save, actually, money and time. So it's, I mean, the more string-oriented or string-heavy your application is, the more you're going to benefit from that.
Okay, thank you.
Thank you also. So I guess it was the last question because we have some time and need to have rest and coffee break. Let's thank to our speaker. Thank you very much, Piotr.